Good turnout for anybody watching this recording afterwards. Hopefully you can see my screen. If I put my deck into presentation mode, my computer crashes, so I'm not going to do that. But we're doing prescriptive analytics with Synapse. I have a GitHub repository where you should be able to run all the code even if you don't have Synapse. So I'll leave it there. And you can kind of check that out. So my name is Dave Wentzel. I work at the Microsoft Technology Center, which is normally where you guys have your Philly .NET meetings. If this wasn't COVID, just a little bit about what we do. I'm not going to go over this slide, but we're a free service to customers. So if you see anything today that's interesting, we can help you do it. Specifically around rapid prototyping and envisioning workshops, or actually what it is design thinking. And I'll talk a lot about that today because those two are the trick to getting analytics projects to work. So that's that. I'm not going to do that slide. Here we go. All right. So what we're going to talk about today, oops, sorry about that, is what I call prescriptive analytics. Okay. So this is my term, but I believe the industry recognizes this as being a standard term as well. Although 20 years ago, prescriptive meant something else. And if we have time, we'll discuss that at the end. So here's the way I like to think of it. When you're doing data and analytics, there's kind of a life cycle or a maturity that kind of goes along with that. As we go out in the continuum, and I can't draw worth anything, but the analytics gets harder. But the value becomes more valuable. Okay, so just roughly, what is prescriptive analytics? So start with descriptive. Okay, descriptive is a Power BI dashboard or SQL Server reporting services report, something like that. It's basically telling me what happened in the past. Okay, a lot of times with Power BI, if you see a graph and it does something interesting on the graph, you can double click it and it'll kind of do a drill down or a drill through. That would be diagnostic. So you're looking at why did it happen. Probably everybody is familiar in 2022 with what predictive analytics is. So that's using machine learning. Okay, but what we're going to talk today is prescriptive. So what prescriptive is this is really what executives and business leaders want out of their analytics. They're really, I'll be honest with you, they're not really looking for predictive ML algorithms, okay? There's not a lot interesting that goes into that. And most executives, they're kind of overwhelmed with the number of Power BI or Tableau dashboards anyway. So what they're looking for is the prescriptive. So that is, let's take a look at some data and let's see, can we form an opinion on what that data is trying to tell us? Okay, so this is kind of what executives are looking for in data projects nowadays. And this is kind of a little bit difficult because it requires us as technologists to basically form opinions and normative statements about data. So instead of just saying last quarter's sales numbers were X, we're actually going to say last quarter's sales numbers is X. And based on what the data is telling us, we're going to form opinions and say to make the, to get better revenue, we should be pulling these business levers. So that's what we're going to talk about today. And, there's 1,000 use cases for this. I'm going to walk you through just a few. And the technology is not as interesting as the patterns, the analytics patterns. And anybody can do these. It's very simple. We're going to use Spark and Synapse today for the most part. Okay, generally, if you're a data professional watching this later, what you'll find in most corporate America data projects is this is kind of an internet meme, but what you'll find is a lot of people say, okay, we're going to build a data warehouse and then we're going to put some Power BI dashboards against it. And then boom, suddenly there's business value there. I kind of equate that to how you draw an owl in 2 steps, which is the internet meme. It's draw 2 circles and now draw the rest of the arrow. It's the same thing, right? When we say we're going to do a data warehouse and we're going to attach some dashboards to it, you've missed all of the fun that goes with the analytics and the storytelling about the analytics and the being able to express opinions. So we're going to look at that. It's actually not that hard to do, but it's something, again, technologists tend not to be comfortable doing. All right. So again, there's the GitHub repo. If you're watching this, I have tons of other examples, but we'll just kind of dive right in. I'd ask anybody if they have questions, but they don't because there's nobody on the call. So just real quick, if this is anything that's interesting, on Monday, I'm doing a session on marketing analytics using demand signal repositories. It's not going to cover what we did today, but it'll cover things like that. So again, it's very prescriptive. What do we do next? So if you're interested in that, send me an email or hit me up on my LinkedIn address, and I'll be happy to send that to you. It's free to attend. We have sessions coming up around this as well, which is if you're a data person, ETL is kind of on the way out. I'll show you a lot of cool ways to avoid doing ETL. That's in, I believe, 2 weeks. I have something called latent data analytics, which is there's a treasure trove of information in corporate America that nobody's even thought about querying to gain insights. So we're going to do that. And then we're going to look at the last week. This is actually part of a series, but if anybody's interested, again, hit me up. We're going to look at how to build a decision factory, which is essentially how do I make prescriptive analytics part of my journey with data. Okay. GitHub repo. Again, you should have it. You should be able to get it out of the video. And these demos that I do today, these are you can reproduce these on your own, even if you don't have a Synapse environment. And I have lots of other repos out there as well that go over interesting things like this, ways to think differently about data. Okay, I have a lot of text here. I'm not going to read this all to you. We'll just start with some demos here. So I'm not sure we're going to get through all of these demos, but some of these are fun. And you'll notice there's just a pattern to them. Okay, but it's things I want you to think about if you're going to do analytics, with your executives in corporate America. At least something a little more fun than just doing, a couple of Power BI dashboards. Okay, so let me demo this for you. We'll start with this first one here, okay? And again, I think prescriptive analytics, so when we're saying prescriptive, we're prescribing a path forward for the business. It requires a pattern, okay? And one pattern, if you're a data-centric person, is to use this thing called CTAS. I can probably make that a little bit bigger, okay? And CTAS just stands for Create External Table as Select. Okay, so I think in 2022, data lakes are probably a great replacement for data warehouses. If you've never had or seen a data lake before, I'm not going to go into that too much detail, but I have other sessions from previous Philly.net code camps where we do that. So if you can search on wherever we keep those, you should be able to find it. This is my Synapse environment. Just real quick on Synapse, okay? To spin up a Synapse workspace is free of charge, and it's extremely inexpensive if you do things the way I show them to you today. It's extremely cheap, almost to the point of just being pennies. There is a feature of Synapse we call dedicated pools. They are very expensive, and they're meant for very high-powered analytics. I don't usually use that, to be honest with you. So as long as you don't use that, this should be cheap and you should be able to reproduce this demo. I'll just show you my Synapse environment here. In corporate America, we're moving towards data lakes. So if you have a data lake, great in your organization. If you don't, really what most organizations are doing nowadays is having multiple data lakes, okay? And that is the data lake that is the corporate data lake, and then just miscellaneous sandbox and line of business data lakes. So if I show you mine here, let me show you this real quick. Here is one of my data lakes. You see I've got a whole bunch in here, and a data lake is just data that's structured in files that you can query using a SQL abstraction or possibly Python or something like that, okay? My data lake is known as a data swamp. It is a complete mess, and that's just because I'm extremely lazy. All right, but if I take a look at this here in my data lake, and don't ask me why it's called WWI.02, that's a wonderful naming convention, but I have some sales data here that I can query, okay? And if you notice here, it's structured on the time axis. So all these folders are at the time axis. If I pick one of these under the time, I have the quarter. So it's just a folder structure. That's all a data lake is. Under quarter 4, I have month equals 12. And then I have individual days. And you can kind of guess that there's 31 folders in there based on how I've done this. And then here I see this is a Parquet file. If you're not sure what a Parquet file is, don't worry about it. You don't really need to know, because all we do here is say, I want to look at what's in this data. Now, when I do that, you notice I'm in the 2019 December 1st file. I should be seeing, if I followed good best practices, semantically, this is telling me that whatever query I execute should be showing me data from December 1st, 2019. Okay, writes a little query. This query is just, again, this is the way you pay for this service is it's just pay per query. And it's very inexpensive when you're not really querying huge data sets, which I always tell people, start with small data, don't immediately graduate to big data. But it's just standard SQL Server syntax. So it's transact SQL. The only thing that's interesting is this syntax says, here's a file I want to look at instead of a traditional SQL Server table. If I look at this, first time I execute it, what this is doing in the background is spinning up a Docker container. So the first query always takes a few seconds. And the last thing I'll say is that notice it's at 9 seconds already. This is not meant to do online website hosting, this tool. It's meant for analytics and exploratory analytics, which is what we're going to do today. Took 12 seconds. Next time I run it probably takes like 2 seconds. Okay, but it's not going to blow your socks off. This is not a replacement for your Oracle data warehouse. Okay, it's not its intention. But there I've got my data, so I can look at here, and then anything I do in SQL I can do directly from here simply by looking at that file. So if I want to see approximately how much data is in this file for just, remember, December 1st, 2019, it's about 371,000 rows. So it's not big data, not really tiny either. And notice that one came back sub-second. Okay, so that's what we're looking at here. All right, so let's take a look at kind of the first demo here, which is I'm going to show you how to do this stuff in, this is called SQL Serverless, by the way, because it uses Docker containers, but it's a great way to do exploratory data analytics or prescriptive analytics, okay? So I showed you how to just query a file in the lake. Here is, if you want to do this on your own, here is one that I'll show you how I think through doing EDA or exploratory data analytics using a data lake. In other words, using files that are stored in a data lake instead of a traditional SQL Server database. And why would you want to do that? Pretty simple. The reason why is it takes time to ETL data and get it into a SQL Server. We got to deal with data types and null values and all that kind of stuff. It's much easier to just query the data in the files where it lives. That would be the theory. Okay, so here's a standard template that I use whenever I'm out at a new customer or I'm working on a new project. Okay, and you can take the one that I have out there in the Git repo and modify it for your purposes. Okay, now if you're familiar with Jupyter Notebooks, we'll use those next, but this is just if you're a SQL person. Okay, and what we find with prescriptive analytics is you're going to have people working together. There might be some data engineers. There might be some website people, that are helping out on the project. There's going to be business analysts, executives, and we need to make sure that whatever tooling we do for analytics, everybody can use it without having to learn Python or something like that. So that's what we're going to do here. So here I just do this in SQL. So SQL is kind of a bleh interface, but the next one we'll take a look at a Jupyter Notebook. So here I'm just going to give you a basic business problem. So there is a taxi set out on the internet. It's the New York City, I think it's called Taxi and Livery Commission or something like that. And they provide all of the taxi rides going back, I don't know, at least 20 years. And we want to just solve a business problem. Okay, so we want to say there's a few anomalies in our data where our ridership drops off if we're a taxi. And we want to figure out what could that cause be? Could it be weather? And then we're not really getting prescriptive yet. So we're not saying how do we solve a weather problem that causes ridership issues. But let's just start with basic analytics and not get too far in the weeds with it. All right, let me show you what this data set looks like real quick from a file perspective. And I forget where I have this. I can do it this way. It'll take 1 second. All right, so here I take a look at, and I can never find this stuff. It's not that one, it's this one. See, this is the problem with having too many data lakes. There we go, it's this one. So if I look in my data lake, I have New York City taxi staging. Okay, if I take a look at this, I have transactional data. So there's a folder for that and lookup data. Lookup data would be like stops and, holidays and things that don't change. And you'll notice here I've loaded up data from 2009 to 2017 and I stopped after that. I have data in other places. We'll get to that in a second. But here, if I take a look at 2017, you can see I stopped loading in June. So notice this follows a trend. It's very similar to how I laid out the other data lake. And you'll find there's always patterns. There's no one way to lay out a data lake, but it's all pretty much follows the pattern. So if you follow this type of pattern, it works pretty well. So if I look here, I'm in June 2017, and now I have yellow taxis, green taxis, and I forget what FHV stands for, but it's basically Uber and Lyft. All right, so if I look in yellow, this is the data as it comes right from the New York City Taxi Commission, or TLC, I think it's called. So that is their data file they give. And notice for yellow taxis, it's about 800 megabytes. So it's a large CSV file. You're going to have a hard time opening that in Excel. But let's try and do some analytics against that. So here's the template I use generally. Okay. And in this Synapse tool, again, it's what's called Synapse Serverless, which just allows me to run queries over files. So it's basically SQL Server without a storage mechanism. There's no persistence. Okay. So here I call this Taxi Analytics. I create a database just like you would in SQL Server. And the rest of this here is just boilerplate. You have to do it every time. It would be nice at Microsoft if we just made this a standard and we didn't have to do this. There's absolutely nothing you have to change here. You just have to do it. Well, possibly you could give a better password than that. But, that's my password. Now you should be able to run all of this, like I said, in your environment using my code. And it'll cost you maybe about 13 cents to do it. It's not expensive. Okay. This is also boilerplate. So what this does is says, I want to connect to my data lake that I'm going to use as my sandbox. Okay. So my data lake is called my sandbox. Now that you'll have to change, but all of the rest, I'm just setting up the security. Nothing has to change there other than that path. Okay. Now here, I'm going to show you my data. So I showed you one data set that I have. Here's another one. It's actually the same data, but I have it in 15 different places. And if I look down here, it's under Lake. And then I think it said gold. So there it is. And it's NYTLC yellow, I think. Let me just go back and look. Nope, it's NYCTLC. NYCTLC. No, I don't even see that one. I think it's under yellow here. I think I called it different up there. You notice it's the same data here. Okay. There may be some data quality issues because it looks like I have data from 2026 and 2029. Now, I actually give you access. You can run queries against my data lakes. Okay. So everything you see here, again, it'll work for you. Okay. So here's my data again, where it exists. And now I need to, so let's just pretend here I'm in my own environment, but the way we do prescriptive analytics is we don't want to do ETL. We want to query data where it lives. So why would I want to ingest data from a third party if I can connect and query it remotely? Okay. Now, if you do this back, yourself later, you're going to query my data lake. I'm going to query my data lake as well right now, but this could be anything. Okay, so a lot of companies nowadays, they provide data as a service, and they provide their data sets so that customers can subscribe to them. If somebody does that for you, or you license data from Dun & Bradstreet, you can follow this paradigm and connect to their data. This is essentially the password that you use. It's called a SAS key. And now you can do queries against that data, and you never have to ingest it into your system. Probably anybody who's watching this or on the call, if you use Salesforce, Salesforce has something similar. I can query the data using standard SQL, and I can kind of merge it and kind of mash it up with the data that I have. So here, this is the pattern I use to connect to a remote data lake. Okay, this could even be my corporate data lake. Okay, so in this case, you're connecting to mine. So I call it Dave W Demo Lake. That's my name. Okay, and that's my path. That's my SAS token. And all the SAS token says is I give you, can't click there. The RLE stands for read, list, and execute, if you're familiar with POSIX paradigms. So you have read access to my data lake. Okay. And then I am going to query against the gold, which I think I showed you. There it is. Gold, New York City TLC yellow. And then I abstract out the year, the month, and all the files in there. If I go back and look, they're single file Parquet files. Actually, they're multiple Parquet files. Sorry about that. So everybody's data lake structured a little bit differently. That's how this one is. And you can go out and examine this on your own. You kind of have to, every time you're exposed to a new data lake, you kind of have to learn it. And then here, I'm not actually going to run these because it will take a couple of minutes to run some of these things. But if you can, visualize it, just running a select top 10, I want to make sure that I've actually got a valid connection. So that's just testing my connection. Now I'm going to do some analytics here, and I just do everything with standard SQL. So let's say I'm trying to familiarize myself with this data because I want to do something prescriptive. So, it's hard to look at a lot of data, and the New York taxi data is a lot of data. So it's easier to just say, let's look at 1 decade's worth of data. So here I say, Okay, I want to look for everything from 2010 to 2019, so in that decade. And if you're wondering what this syntax is, it's very simple. Where it says .file path and then 1 and .file path 1, what that's saying is, well, that's the NYC. Okay, the file path 1 says replace the first star. So, it's not 0-based arrays, it's 1-based arrays. It says replace the year with whatever comes in here. See how that works? So now it's pickup year is 2010, and my second one is pickup year, first star, 2019. And now that's going to do the filtering for me. Pretty cool. And now I say group this by year, and I'm going to actually execute it. Again, just in the interest of time, I think you know what that's going to come back with. Okay, it's going to show me some data that I can then kind of take a look at here. If I take a look at this data, I'm actually going to run this so you can see it just real quick, but you can run it on your own if you want. It is going to take a little bit of time because you're querying, even I am right now, the way I have this set up, I'm querying a remote data lake, okay? So whenever you're querying a remote data lake, it's not always going to be fast, but that's not the point. The point is I don't want the execution to be fast. I want to be able to do analytics quickly, okay? So that's the key thing. I don't want to have to do ETL, said differently, okay? That's going to take a second to run. Let's just go on here. I can show you this when we chart it out. But what you're going to find is a lot of times you're doing these remote queries and it's taking 40 seconds and it's just slowing you down. So again, here's what you do. You have this CTAS pattern, okay? And the CTAS pattern is I just take whatever the original query is, okay? And I say, take that data and put it in a new table. So it's almost like you're building a temp table. Okay, and here I say put it in my sandbox. So you don't have write access to my data lake, but you will to your sandbox if you set this up. Here I say write it out to my sandbox, and it's going to be Taxi 2010's decade. Okay, if I take a look at that, if I go up here, my sandbox is here. Okay, and notice I keep my sandbox kind of clean, but there is my data at the decade level, and it's got all these Parquet files in there, and they're pretty big. Okay, if you notice that each one's give or take, it's about 1 gigabyte, and there's quite a few out there. So that's what a sandbox is. Now I've made a copy. The theory should be, let me go back to my code. The theory would be, okay, so that took 1:27. Oof. All right, but you'll see there's a lot of rides here. I say, if I'm not mistaken, that's 169 million rides. I don't know. It's hard to see without the commas in 2010. And if I take a look at this, it starts to drop off when we get down to 2019. If I look at this in a chart, okay, so all I do is click the chart. Oof, I can see ridership. It goes down on a year-over-year basis. And that probably makes sense if you stop and think about it, because I'm only looking at the yellow data. And as we all know, Uber and Lyft is, they're putting the taxis out of business. Okay, so that's the interesting thing. But again, ran 1:27. That's a lot. So in theory, I can make a copy of that data and I can put it in my sandbox. Once I do that, now it should be very fast to do. Okay, and I can do my analytics against that data, and it should be fast. Okay, now, if I go and I take a look at it, now I can just run queries against that. So let's say I just want to look at individual days now. Okay, now here I'm not going to materialize that data because I've already done it. So here I'm going to run it and say take a look at just 1 year, so 2016. Or I'm sorry, within 2016, I want to look at the data aggregated at the day level. That's what this is saying. Again, notice it's a little slow. Okay, so again, you can probably figure out what we're going to do next. But what we can do is we can aggregate that data by day. And I'm just going to cancel this, okay? And here's what we do. We actually aggregate it by day here. I take that same query and I CTAS it to another area in my sandbox. That's it. So now I have this data, which is 2016 by day. Now if I look at it, it's wicked fast. Boom, there it is, okay? So that's what I'm doing with CTAS. I'm making things faster and I'm slowly semantically enriching things. The theory would be if I do that, I don't have to know a whole lot of SQL, and it makes the analytics very simple. I'm just pipelining this stuff together. That's all I'm doing. Pretty easy. Okay. So if we take a look here, what can we interpret out of this data? So if we're trying to increase ridership or something like that, what trends can we see in this data and what can we make any recommendations? Well, it's hard to read this unless I fiddle around with the graph here, and I'm not going to waste your time to do that. But trust me on this, if I look at this data at a weekly level, Saturday is the peak day. Okay, it looks like we could actually write the query and do that, but there's some significant drops that don't necessarily fit the seasonality trend. So actually, if you look at this, it's probably obvious, but there is seasonality to this data set. In other words, there's less riders in the summer than there are in the winter, and that probably makes sense. Okay, but there are some significant drop-offs here. Okay, there's some significant. What would that be? Okay, so let's say we have a theory it's holidays. All right, so we want to say, is it holidays? And then maybe what can we do to increase ridership on holidays? Okay, so if I have a holiday data set, awesome. If you don't, guess what? You can connect to a third-party data lake and you can find holiday data. There's tons of them out there. Here's one we have in Azure. It's called the Azure Azure, I can't say that. You know what it is. You can read it. It's a series of Parquet files, and it has holidays for all the countries for all the years. So what I do here is I create a view, which is very similar to an external table. It's just I'm not materializing the data if you're familiar with views. So here I want to say I want to just look at United States holidays in 2016. Now, if I run it, so now I do the join, okay? If I run this, hopefully it's fast, it is, and I think I need to change this to, I can't remember what the is it holidays are in the category name? Yeah, okay. Well, this doesn't show all of them because I'm not zoomed in far enough, but you get the idea. Here I can look here, New Year's Day, there is a drop off. Memorial Day, there's a drop off. Looks like Christmas Day. It didn't put all the other holidays in again because of the zoom settings. But here's an interesting one. If I look here, this is not a holiday. I don't know if you can see that. It's not a holiday, yet there's a significant drop off in ridership. So why is that, and what can we do? So this is where we would do design thinking with executives and say, do we have like a theory on this? And maybe it's weather. Okay, so we say here, is it weather related? Okay, so how do we find out if something's weather related? So a lot of companies nowadays, they want to know, can we use weather data and integrate it with our existing, sales data? And, in other words, can sales data, help us improve revenues, or maybe it helps with supply chain, something like that. So where do you get weather data? Well, guess what? We got that out there too. There's lots of places on the internet, okay, but I don't want to ingest or do ETL to go and get that data for one-off analytics. It's going to take too much time, okay? So what I do here is we have one sits out in Azure. And again, I structure it by the weather year, month. And again, there's documentation you can go out and you can visually explore it. I'm not going to bore you with that. They're in Parquet files, which are optimized formats. I say I want to see the weather in the US for that date. That's the date of the drop off. Okay. And the nearest I want to look at is John F. Kennedy Airport. Okay. That's just something I picked. There's probably better ones. But if we take a look at that, and I'm not going to bother to integrate with the existing query. Now, this data set is huge. Okay. We've got the data set, this particular data set, if I'm not mistaken, goes down to the minute. Which is why I have to do all the aggregations here. So it's dog slow. As you can tell, I'm pulling back one date. But again, remember, we don't want to have to ETL the data to do one-off analytics, and that's what prescriptive is, okay? So let me just take a step back here real quick whilst that's running, and I'll explain to you an example in case you're not sure of what prescriptive analytics is, okay? Imagine you're a data person or you work in IT, and your executive comes up to you and they say, we spend $10 million a month on Facebook marketing campaigns. Should we spend more? Should we spend less? What is the return on investment? If we spend more, does the return on investment improve, or is it law of diminishing returns and it does not improve? And should we be spending money on Instagram campaigns? So those are interesting questions. That's prescriptive analytics. So we're saying, let's look at data and let's form an opinion. Okay. And when we form that opinion, we want to be able to say the opinion that we have is we should do this. And here's why, based on what the data is telling us. So that's what I call one-off analytics, right? So if you stop and think about it, why would I take Facebook analytics data? And by the way, I'm going to need Google tracking pixel data. I'm probably going to need customer information from Facebook. I'm going to have to marry that with my existing customer list, which is no easy task. And I want to do that really do I want a Power BI dashboard? What's a Power BI dashboard going to say? Should we invest more money in Facebook? Yes or no? Okay, that's not a very compelling Power BI dashboard. It's probably something you're going to do once and then you'll never do it again. Or with Facebook analytics, you might say, I'll do it now and then maybe we'll do it again in 3 months. Okay, so why would I load any of this data in a data warehouse? That's the thing. So it's one-off analytics. So here, this comes back. Remember, this is January 23rd, I think was the date we had issues with. So here it says this all, you'd have to look at the documentation, but this is all in metric. So here it says it was a windy day, so that's 14 kilometers per hour. It was -2 degrees Celsius, so it was cold, basically below freezing. And here it was 17 centimeters of precipitation that occurred that day at that spot, and within there, the average throughout the day was 29 centimeters. So it basically snowed, and that's why there was such a drop off that day. So that's prescriptive analytics, kind of a boring use case, but this is the pattern. You're always sitting here and you're saying, get me some data. Now let's think through it. Let's look at the data, and then it's going to be slow because we're dealing with big data sets. So let's carve the data down a little bit. Let's CTAS it, and let's continue to look at it. Okay, so that's a very simplistic example. All right, you can read through here. You should be able to do all of this. I even have one that you should be able to run in a dev container. So if you clone this repo and you know how to use dev containers in VS Code, you should be able to run all of these demos without using Synapse as well. So I have all that here. Let's show you another one of cognitive mistakes. This is a very hot topic. Again, prescriptive analytics, and just we want to make sure we don't make mistakes when we're looking at data. Nothing worse than that. So here's an example. I'm going to use this Synapse tool. This always throws people for a loop. Okay, now we have a lot of developers and programmers. They'll probably catch this right away, but a lot of times even data people don't, which is sometimes embarrassing. Okay, here's what it is. This is a Jupyter notebook here, and here's a business problem. Okay, our company builds stuff. All right, I'm not going to read this whole thing to you. We need to buy a drill. Drills are expensive. That's a cheap drill. I just picked up, off of Google Images. But let's say we need to buy very expensive drills and we want to have the vendors come out. They're going to set up drills and they're going to demo, and we're going to test their drills and see if it meets our requirements, because we have very specific requirements that we need for, oops, let me just see if I can zoom. Sometimes there's something wrong with this browser and I can't, I don't know. It's probably JavaScript. I should probably get one of you guys to figure out what's wrong with my machine, because I know nothing about JavaScript. But anyway, here we want to say we want to run a series of experiments on each of the 4 drill presses before we buy them. And we want to drill 100 holes that are 3 inches of 3-inch diameter through a big chunk of steel, and we're going to do it in 2 hours. Okay. Each drill press is going to get one of our good operators, and we're going to see what the measurements are, and then that's going to determine, that's going to be one component, including price, that we're going to use to determine if we should, or I'm sorry, determine which drill we should buy. Okay, I need to scroll out just a little bit, which is always a challenge. Here, this is my data in my data lake. Again, you'll have access to this if you want to run these on your own, and you can, by the way. Here I see it's gold drill data. Let me just show you what this data looks like. Gold drill data. Give me a second. That's lake gold drill data. Okay, and it's just a CSV, right? And it's a tiny CSV. But if I right click it here and I want to take a look at this, I say select top 100 rows and I execute this. And up, we can instantly see it has header rows because CSV files don't always have the header. This one does, and it's a very small data set. Doesn't look like we're missing any data. It all looks like it's good data. You know, it's not really a huge data set. All right, always start with small data. So let me get rid of this. And I don't care, you can discard my changes. And let me go back over to, where was it? This one. Okay, so here, this is how I'm going to connect to this data set. And this time I'm not using Synapse Serverless. This time I'm going to use Spark. Okay, so if you're familiar with Spark, that's what we're using here. We could also run this in Databricks. Databricks is Spark. Why did I choose Spark? Spark works well if you're switching between SQL language and Python language and you have big data. Obviously, this is small data, but bear with me, okay? Because we just like to keep this stuff simple. So this is the pattern I follow, and you're going to see this over and over and over again. Well, we only have a couple more minutes, so not too long. This connects to my data set. here's some standard stuff I have to do in Spark. So that's Python nonsense. Here I go and I say, take a look at the data. So here I load this into a data frame called drill. It's my drill data frame. Okay. And I register it as a SQL table as well. That's what that little piece of code. Now I can go back and forth between Python and SQL. There's my data. It figured out the header. That's cool. All right, you always got to deal with data types and data land. Here, it brought everything back as strings. That's annoying. We'll have to fix that. And here, anytime you're looking at something in the Spark tool, if you just take it and wrap it in the display, you get this really nice interface that allows you to scroll and you can chart your data. Okay, now that's not charting well because the data is still not in numerics. It still thinks it's string. Okay, you can do all this on your own. So here I say, what does this data look like? Okay, so I'm just going to look at it. So now here I've noticed I've gone back to using SQL, and the name of my table is what I registered. So this is where a data scientist can work on her piece, and a data analyst that just knows SQL, or a business analyst, they can do things in SQL, and we can kind of collaborate together. And that's the beautiful thing. We can collaborate. And if we get our data to tell a story, this is interesting. We can show an executive this. So let's take a look at this. So this is what the data looks like. We've already seen it. There's our drills. There's 100 rows. If you remember, we were going to do 100 trials. I don't know why that came up. I think I have a carriage return line feed issue somewhere. But here I take a look at this and I say, let me see this data. And I change it and I cast my columns so that they show up as numeric. So that's all that is. Okay, I could have done that with SQL. If everybody knows how to use the cast statement in SQL, I just chose to use Python. Okay, we can mix and match. Here's what I like to do, and you can't really do this in SQL. I want to see the summary descriptive statistics. Okay, so this is what a summary screen looks like. It says my count is 100. Notice when it says 100 all the way across, that just means there's no nulls. Okay, here if I look at, there's my mean hole size. So my mean hole size is, remember my goal is I'm supposed to drill 3-inch holes. So my mean is 2.98. There's 260, there's 290, and there's 3. So this one over drills a little bit. Okay, so just looking at this data, I love to do this with executives. Which drill do we recommend? Just looking at this. And most people will say, well, you know, the average hole is 2.98, which we under drilled. That's cool. The best one is drill D. We should be using that. But should we? And this is where you have to really kind of understand your data. And this is where design thinking helps. When we all sit in a room, we can form opinions and look at the data in interesting ways. Okay, so just looking at this, you might say drill D is what we should recommend because it's got a good average, a good mean hole size. And drill C was the worst, right? I mean, it's nowhere even close to any of them as far as what the mean size is. But maybe there's more to it than that. Okay, so here I'm going to run the display command, and now that I've got the data with the correct data types, it'll map easier. Okay, I could do this with SQL as well, so I could say select star from df drill 1, but I'm not. So there's my data, and now I'm going to chart it, and when I chart it, it pops up this way. Okay, now we see some interesting things, and you probably see the problem already. So if we look at drill D is the one we thought we should recommend up here, right? Because it had the best mean hole size. But now look at that. Remember, the goal is we want a 3-inch hole. That thing's horrible. We should definitely not recommend that. Now let's look at drill A. Drill A, it looks pretty good. Okay, there's some precision there. It's not really all over the map. You could roughly say that it over drills, and drill B is very similar, but you could roughly say it under drills. Okay, drill C, look at that. So that's the one we thought did the worst based on the mean. But looking at that actually doesn't look too bad. I mean, it's extremely consistent. Okay, when we look at data, executives have this problem, and programmers don't usually, but executives do, and business people. This is an accuracy versus precision problem. Okay, you can read all about that on your own. But when you're looking at a mean, you're looking at an accuracy, but sometimes the problem isn't an accuracy problem, it's a precision problem. And precision is better looked at via standard deviation. Okay, so if I take a look at this one, my standard deviation for drill A is, that, and for drill B, it's that. So they're not too bad. Drill C has almost no deviation, okay? And drill D has wild deviation. So if we look at this, we could almost say that possibly we should be recommending drill C. And I'll bet you if you sat in a room with people that understand manufacturing and drills, they'll look at this data and they'll say, well, it looks like the machine just wasn't calibrated. So maybe we should go back and run another experiment. So I have down here a little interpretation on how what steps I would recommend based on prescriptive analytics, okay? But it's not something that I myself do. It's something that we do as part of thinking through data problems, okay? So that's an example. It's very simple, all right? Let's take a look at another one, marketing campaign analytics. This is fun stuff, and executives love this stuff, okay? So remember I told you before, a great use case for prescriptive analytics is tell me if my Facebook marketing campaign has a positive ROI. Let's look at an easier example because that one's actually really tough, okay? Let's look at another one, okay? And I like to always have my data tell a story. So I'm going to do social media campaign analytics with a very small set of data. You'll see that. And the question is, should we increase our investment in social media or shouldn't we? Okay. Now, whenever you're dealing with data problems, it helps to be what I call data literate. And that means you understand data. So you understand things like the difference between a standard deviation and a mean. Okay. If you don't, it's not a big deal. A lot of times, if we just do design thinking and we get executives and business people and programmers in a room, people will use their, their background and they'll be able to point out flaws in our thinking. Okay. By the way, I'm horrible at math. Okay. So here's one that is actually a sampling problem. Okay. So if you're familiar with sampling and elections, you know the problem. I won't get into it in more detail, but here we go. I have my data tell a story. So I like to always talk in personas. So we have our CMO, her name is Sheila. So CMO Sheila says, I'm not going to read this whole thing to you, but she says last quarter was our best quarter. We crushed our Wall Street earnings target. She says the reason why is because we revamped our digital advertising campaign and we conducted last summer a comprehensive survey of social media usage at our mall stores. And she gives you this pie chart. And she says the respondents from social media, 52% are on Instagram, and you see it. Okay. She says, you can see from the pie chart that our Instagram presence is expanding. Now, first of all, pie charts cannot show you if something is expanding or contracting. They have no notion of time. So your bullshit indicator should go up a little bit there. Okay. So it says here 52% of survey respondents said that they learned about their company from Instagram. We should double down on our Instagram ads. So basically, she's saying, let's spend money on Instagram. Your CEO is skeptical, says, hey, let's bring in some data, people. Let's do some design thinking and think through this. I love this John Wanamaker quote. I do a lot with marketing people. And the funny joke is, half of my marketing dollars are wasted. Problem is, I don't know which half. And it's exactly this problem. So let's walk through this. Okay. Again, I'm not going to read this whole thing to you, but just see what the thought processes are, thinking with data. Okay. So here I say, there's a lot of background here, but sometimes we just need to start with brass tacks. How did we do the survey in the first place? So if you know anything about surveys, there's a science behind it, and I'm not going to walk you through all of it here, but here's the survey that CMO Sheila said she used. Did you hear about us through social media? Yes or no? If you said yes, which one? Okay, that's actually not a terrible survey. Okay, it's very simple, but it's going to introduce bias. All right. And if you don't know why, I explain it a little bit later. She also says here that when they did this, they wrote down the approximate age range of the respondents. Okay, that's pretty good. Would have been nice if they just asked, but okay, cool. Okay, so right away, we know there may be some sampling bias based on how the questions were asked. Again, more on that below. But we want to, we say, okay, let's actually look at your data. Okay, so let's look at the data. So here, this is my standard. Notice I did this in the last one too that I showed you. We have to do this kind of, this is a little bit of boilerplate code here. So I do that. Notice I connect to my data lake. Okay, here's my data lake. And let me just show you what this data looks like. It's Lake Marketing Analytics Survey. So if I look at Lake Marketing Analytics Survey, small data set, and I just want to take a look at this real quick in Synapse just to see what it looks like. And it's a tiny data set, but it always takes a few seconds the first time. Okay, there we go. So notice it has headers. That's the first thing. Notice, I don't know what a respondent is. That's interesting. If I look through here, it says here the date of the survey. There's the time. Social media. I got a lot of nulls. I hate nulls in data sets. Data people hate nulls. If I look here, this is all kind of interesting. Everything's on the same date. I only see 99 rows. Well, I guess that's because I only told it select top 100. But this is interesting. It gives us a quick look at the data. So let's go back here and let's pull the data apart a little more. So I make a connection. I know it has a header, so I'm going to use a header. I'm going to say, show me the first 5 rows. So here's the first 5 rows, and register it so I can run some SQL too. Okay, and my schema comes out down here. So again, CSV files, you gotta hate them. I can't believe we're still talking about these in 2022, but there's, it's all strings. I got to fix that. And then here again, I got a whole bunch of nulls. I hate nulls. Okay, we got to fix that. So the first thing I'm going to do is let's take a look at the summary. I showed you this in the last one. Summary shows you all the interesting things. So here, there's, okay, there's only 363 rows, so there's 363 surveys. That sounds dumb. That's not enough, okay? That's not going to give you a representative set, but okay, fine. Let's see, there's trues and false for responded. So let's ask Sheila what she's doing with that. Survey dates. There's only one survey date? That's suspicious. And survey times, I have a min and a max. That's probably just because that string, it doesn't look right. Well, we'll have to verify that. And then social media awareness is, again, a true or false, but I also remember seeing some nulls in there. Okay, so let's take a look at this data here. So I took a screenshot there just because sometimes it doesn't save the graphics. So we should be telling Sheila, man, you know, there's an entire science between how large the survey is, but if you know anything about confidence intervals, the confidence intervals for this is pretty much nil. We can assume that, but that's fine. But when we look, the interesting thing is the survey, or I'm sorry, the respondent is false or true. So in other words, did the person, when they asked them, did they actually respond and answer our questions? So there's 363 attempts to get a survey answered, but not everyone answered. So it's even worse than we thought. Okay, here if I take a look and I say, all right, let's see what the breakdown is. So here I flipped over to use SQL. I could have done this in Python as well, but here's the SQL. I say who responded, who didn't, and give me a count. So I have 235 out of the 363 that didn't respond, and I have 128 that did respond. Again, when I run my query this way, I can chart it real quick, which gives me a pie chart. It's very smart. And this is telling me 65% did not respond to my survey request. 65%. Said differently, our response rate was 35%. If you know anything about marketing, and this is where, if you don't, this is where you sit with marketing people in a design thinking session and we talk through this. A response rate of 35% is just, that's a horrible response rate and it shouldn't be trusted, but I'll let you research that on your own. Okay, so we start asking CMO Sheila a few questions about how the survey was conducted. All right, and we find out that she conducted this at the entrance to a single retail store in the middle of California as the shoppers were leaving the store. Again, I'll leave it as an exercise for you to research on your own. That is a terrible way to conduct a survey. But let's look at the data and forget that. So here I run some SQL and I say, when were the surveys conducted? And we already looked at that, but they were only conducted on one day. And if I look out there, that day of the week was a Tuesday. Okay, that's a problem. Now, if I look down here, what were the times? So the times were, forget the 1970, it's just because I didn't bother fixing the data. But here it looks like we started and we did surveys from 9 to 5. So we did surveys on one day of the week from 9 to 5, and that day of the week was a Tuesday. Stop and think about who's walking through a retail store on a Tuesday morning in the middle of summer between 9 to 5. Is it going to be your buying demographic? Well, that depends. If you're marketing to children or to geriatrics that are taking their walk and getting out of the heat, then yes, otherwise that ain't your demographic, okay? So we go through there and, you know, we talk to CMO Sheila and she says, here's the breakdown of age data. I didn't write the query, but here you can see it. And she says, this is the breakdown. I'll let you see it there. And she says 83% of the under age 40 demographic was captured in the survey, and that's our target sales demographic. Is she right? Yes. If I aggregate these two together, it's 83%. But is that true? Okay, so this is where if you don't aggregate the data smartly, you can lie with data. And if you're familiar at all with Simpson's paradox. Misaggregating data is the easiest way to lie. Okay, so here, yeah, she's right. It's 83% the target demographic, but really, under age 40 isn't the target demographic. Is if we're positively skewing the data to the 12 to 20s. A positive skew means there's more on the left than on the right. If we tried to draw this as a normal distribution, okay. In other words, the right side would be a negative distribution or a negative skew rather. So she's right, but that's not exactly how I would interpret the data. So here's the original graphic she gave us. 52% are using Instagram. If you remember, not everyone responded, right? Our response rate was only 35%. So I did the math here just to be fast, but really we should redo this graphic for her and we should say of all social media, okay, only 43% are using it and their children. And out of that, only 22% are using Instagram and 9% Facebook. So this, I would say, is maybe a lie. Maybe it's just a stretch of the truth, depending on how you play with the data. Okay. When you do this stuff with executives, they love it because we're thinking through the data as a group. And notice this tooling, these are called Jupyter Notebooks, really helps to get your message across. Okay. Here's some things down here. So what do we recommend? Remember, we're trying to make what do we do next style recommendations. Here, I'll let you read that on your own, okay? So that's it. I've got really like about 2 more minutes. I just want to show you one more thing. Now, this I don't do in Synapse because people get a little freaked out when I show the data. But let me just show you how to do it, just math. And this I find fascinating. You got to give me a second. And this is out in that repo as well, okay? And that repo has a dev container that you can start up in VS Code. I have a notebook out there called Prescriptive Analytics, and you can run it yourself. Okay, here's what it looks like. Notice I'm running in a dev container in the bottom left. Okay, and I just use a dev container because I've been using Python for many years and I still can't figure out how to get it to run on Windows. Here I have all kinds of explanatory text about what prescriptive analytics are. You can read that all on your own if you care. There's all kinds of stuff on what we can do. Here's a use case that's a marketing problem that I call dwell analytics. By the way, dwell analytics is probably the largest thing in analytics right now. So if you want to know what that is, it's basically we build our business problem in terms of queues, right? So we think, and that's what where the dwell comes from, is how long is somebody in a queue, and then we can do interesting things like we can say, as users come in and out of a retail store, we want to know, should we, move, workers around from the register to, back in electronics, so forth and so on. I do all kinds of stuff here. This is the interesting one. You can look at that on your own. If you've ever heard of LP or linear programming, this is the lost art of analytics in 2022. This is fascinating. I'll do this very quickly in 3 minutes. Okay. You can read all this on your own, but basically here's the gist. You use linear programming anytime you have an optimization problem. So in other words, I want to maximize profits. Okay, or I want to minimize the time it takes to build something, or I want to maximize how to pack a bin or a shipping container, or I want to maximize the route that UPS takes to deliver packages today. These are all things that are solved with basically 5 lines of code. You'll see it in a second. What you do is you express your problem as a series of constraints. Okay, using predicate style logic. In other words, like a where clause would be. Okay, so here I say something like labor hours has to be greater than 0. So that's pretty basic, right? I have to have positive labor. And here my labor laws state I have to have, $50 and we don't want to spend more than 100. So I can plug that kind of stuff in. Okay, here's an example. You can read all this on your own, but this is fascinating. I find this fascinating, how we can do this with math without even using data. Okay, then when we plug data in, it becomes really interesting. So let's say we build 2 products, Q1 and Q2, and we have 3 inputs that these products need. Q1 essentially needs 1 of X1, 1 of X2, and 2 of X3. Okay, we have 18 X1s available, 8 X2s available, and 14 X3s. Can we tell how can we maximize, or what should be the mix of products we build to maximize if, and I put another constraint in here, you can read about it, I want 2 times more Q2s than Q1s. And so here's my equations. Here's how it looks in linear programming language. You can read all that above. This is the code. Okay, it's a little, goofy looking because Python's a little goofy looking, but it's not that hard to do. Here it comes back. This comes back almost instantly, and it says I can build 13 products. Forget the negative. I explain why that is up there. And those 13 products are basically, you have to double it. I explain that up there. So it's actually 10 of product 2 and 3 of product 1, and that will give me the most given the constraints. Okay, here I can change it around here. Let me just show you how this works. If I take this and I say, okay, we have this, here we're building stuff or we're selling stuff, and we have an amount that we sell something for. And here's how many units we have in stock. We can build the equation, and we come down here and we say we should build or we should make 6 of the first product, 1 of the second product, and my profit based on the amount is 144. And that runs literally in half a second. Now, here's the interesting thing. Let's just do one more real quick. I'm running out of time, but here this one says I can go out here and I can say I need to stock my store shelves, and I have a budget of $100,000. Here's what my profit margins are for each one. How many should I buy? Oh, I also have assumptions in here and how much we think we can sell. That's a design thinking. And here I come down to we should buy 57 of 1, 29 of 2, and that should get us $43,000 in gross profit. Now, I'm going to let you read the rest on your own, but we can do interesting stuff with this data, right? So for instance, we can say what happens if we have a supply chain disruption? So we add that to the equation. What happens if the market changes and we should be selling more of one versus the other? What happens if we introduce weather variables? Okay, randomness we can introduce here. Risk-free rate of return is something accountants love to do. We can do all kinds of interesting stuff. And this is just the math. Once I start putting the underlying data to it using Synapse and my data lake, wow, this unlocks a world of opportunity. And it's extremely simple to do. So that's all I have. I'd ask if anybody has questions. Oh, we do have a person. I don't know if anybody has questions, but we can take those now. And anybody who's watching this, again, feel free to hit me up. Watch the beginning of the video for my LinkedIn address. And if you'd like to ever do any of this with your company, we do design thinking sessions, and wow, are they fun. They really are. And we always find interesting things about data. I can't always say they're successful engagements, if you know what I mean. So I'll leave it at that. Mel, I don't know if anybody has questions or if you want to stop the recording. Totally up to you.
Yeah, I'll stop the recording.